Hello, my name is Walter Unglaub, and this is Physics Involved in Ultrasound Machines. So let's say we have an ultrasound machine here, which emits a sound wave at a particular wavelength and frequency. We want to be able to determine the distance between the machine and some object. So let's say it's a wall that is purely reflecting. It doesn't have to be. If it's not, then some of the sound will be transmitted, absorbed, and the rest will be reflected. Now we need that reflected sound wave to come back so that we can detect it with our ultrasound machine. And we know that if the sound has a particular wavelength and frequency, the velocity will be equal to the multiple between that wavelength and the frequency. And the distance between the ultrasound machine and the object of interest, or the object that the sound wave will hit and reflect, let's call that d. And let's look at the definition of velocity. Average velocity is equal to the change in distance over the change in time. So if at a time t1 the sound wave is emitted, and then we finally hear the echo, the sound wave reflected back to our transducer, our ultrasound machine, at t2, then our delta t will be equal to t2 minus t1. And the change in position will not be equal to d because the signal has to go, hit and interact with the object, and then come back. So our delta x is actually going to be equal to 2d. So if we're interested in determining what this distance is, we need to know what the wavelength and the frequency and this difference in time is for the sound wave. So what we can do is substitute in these values. So I have my average velocity, which I'm going to set equal to lambda times f as per this definition. And that's going to be equal to the change in x, which in this case is 2 times d, the distance between the ultrasound machine and the object, divided by the change in time, which I'll just call delta t. And I just use algebra to solve for d in terms of all the other variables. So d is going to be equal to lambda f delta t divided by 2. And that would be the physics involved with this machine. My name is Walter Unglaub, and this is the Physics Involved in Ultrasound Machines.